the whole point is to show that these rules right here follow the vectors follow the same rules as the regular numbers do, like the associative property, the commutative property, the distributive property down here. They follow all the same rules, which is really nice and convenient for us. That means we don't have to work so hard to learn something else. It's not like matrices. When you multiply matrices together, there's a certain way to multiply it, right? You can't just multiply a number straight across. You have to like multiply and add, and it gets kind of complicated. Well, vectors are a lot more clean than that. You do everything the same. It's like distributing, combining like terms, all this stuff. Okay, and before we start doing some operations with them, really quickly, which of these vectors up here, which pairs are the same vectors?
First and third. No, first one.
Only the first one.
Okay, yeah, this one's obvious because they don't point the same direction, so they can't be the same vectors. Here they're pointing the same direction, but one's a different magnitude than the other, so those are not the same. Now this one's pretty close because they look parallel. Well, they are parallel, but they're still pointing different directions, even though they're the same magnitude. So this one right here, those set of magnitudes, or vectors right there, have the same magnitude in the same direction, so those are the same vectors. Down here, we have a vector, this guy right here, the v, getting multiplied by a scalar. If it's multiplied by 2, then the vector doubles in size. If the scalar is a positive number, the direction doesn't change, but the size does. The magnitude does change. Right here we have 1/2, which shortens the magnitude, yet the direction is still the same. But over here we have something different happening. Now that's the same as 1.5, but it's negative. Because it's negative, what happened to my direction? It's pointing in the opposite direction. These are kind of obvious when I show it to you. It's like, oh yeah, that would make sense. No problems. So now when you go to problems that and solve them, it hopefully makes more sense. Okay, so I guess I only want to do 2 of these. I think C is just starting to get redundant. But let's plug in v right here and see what you get. So we plug in, we have 2, and we're going to multiply it by the vector v, which is negative 2I plus 5j. Now if I multiply those, it's just the same as regular distribution. You get negative 4I plus 10j. And that's our new vector. That's it. Now, really quickly, let me show you a picture that relates to this thing that we just did. You guys see what our vector is now? That's our new vector. Here's v right here. You see v right here? This is v, and it's pointing that way. So that's v. That's the negative 2, 5. That was the original v without it being changed. Then it was multiplied by a 2. And what happened? It just got longer, and now we're at this point. So it still points in the same direction. Now that's not that interesting. This is really interesting to me. Let's see what happens with that one. So with that one, what we would do is we take w, we have 3I plus 4j, and we're going to subtract v. So it's negative 2I plus 5j. So we distribute the negative, and we combine like terms. It kind of follows all the same rules. So we have 5 i's, and we have it's minus 1j, right? Yeah. So minus 1j. And so I'm just going to write like that, and that's our answer. Okay. Now where would that vector be? Like if I were to graph that vector, I think some of you guys are starting to get the point on how to graph this. It would be 5, 1, 2, 3, 4, 5, and then down 1, right?
Yeah.
So that would be my vector, right? Okay. Well, what's this vector right here? Let's see. We start out with w. That would be 3, 4, right?
Yeah.
So I go 1, 2, 3, then 1, 2, 3, 4. So I put a point right here. That's the w vector, right? And then it says minus v. Okay, what's my v vector? Here's my v vector, and it says minus. And so we have to do the opposite of that vector. So what's the opposite of
2 minus 5.
It'd be 2 and then minus 5, right? So check it out. Now, 2, it'd be positive 2i and then minus 5. 2 has me go in what direction?
That way.
Right.
It has you go right, correct? And so I'm at this point. If I go 2 right, 1, 2, and then I go down 5?
Yeah.
1, 2, 3, 4, 5. So this vector actually takes me right to the end.
Fantastical.
That's kind of interesting, isn't it?
Yeah.
And here's a cleaner picture.
Fantastic.
Here's our result. Our result vector, or resultant vector, I think is how you call it. And that's by taking positive W and negative V. It takes us to that same point. That's kind of interesting. Okay. Now here, here we're finding the magnitude after we find the unit vector. Now the unit vector, it has a magnitude of exactly 1. And this is kind of interesting. 5, 5 is right here. So our vector is right here. But a unit vector has only magnitude 1. But this has a bigger magnitude than 1, right? I mean, we just know it's bigger than 1. But let's find it really quick. So if I wanted to find the magnitude of this is how you would write it. We kind of already did it once. The magnitude of this would be 5 squared plus 5 squared, and take the square root of that. We just have to take the distance right here, the distance right here, so we could find this distance, right? Using the Pythagorean theorem, a squared plus b squared equals c squared. And what do we get here? We get, that's 50, no, here, let's go slower. 25 plus 25, the square root of that, and so it's just going to be the square root of 50, which would be 5 root 2. Okay, so the length of this line, the magnitude of this vector right here is 5 rad 2. But we want it to have a magnitude of 1. Do you guys know what this vector would look like? Any of you guys that are extremely bored of your mind, can you tell me right now what the vector, unit vector would be for this one? And you should know it because you guys know the unit circle. And you know what this angle is right here. You should know what that angle is. That's 45 degrees, or you can say it's pi over 4. So what would be my unit vector for this?
That's rad 2 over 2.
Yeah, it would be rad 2 over 2I plus rad 2 over 2j. Now there is, that's our answer for this, that's our unit vector. There is a way to find that. And what you do is you take your vector, which is v, and you divide it by the magnitude. Which actually makes sense, right? Because that, you know that's going to equal 1. It should. Here. So this would be 5i plus 5j. And we're going to divide that by 5 rad 2. So that means we're going to have 5 divided by 5 rad 2 for the I. And the same thing over here for the j. The 5's would cancel out, so you'd have 1 and 1. And then now you have 1 over rad 2, which if you rationalize, it would be rad 2 over 2. And then we would get these guys right here. Ooh, that's kind of interesting.
Essentially, just like
All the points around the unit circle are going to be just 1 unit away from the origin, right? All the points. And so if you have an angle that is a common angle to you from the unit circle, then you know the coordinates. And I picked this just because it's a special case, and I thought it was kind of neat. It's like, ooh, another connection to the unit circle. But besides that, you're not going to have unit vectors that are familiar to you from the unit circle. Okay, I wanted to pick a fancy one. And so anyways, just really quick, to find your unit vector, you take the vector, divide it by the magnitude, and boom, you got it. Okay, now vectors are magnitude and direction. Well, what's another way to find direction? One way to find direction on a line is to know its slope. But there's another way to find direction. We can use angles. And so here we have a little word problem that uses angles, and we have to figure out the vector for that would represent this wind. Okay, so let's see. It says the wind is blowing at 20 miles per hour. That's going to be our magnitude. It's a velocity. It's going in this direction. So to help us visualize, let's draw an x and y axis. And in this x and y axis, we're going to say this is north, this is east, this is south, and this is west. It says the wind is blowing north 30 degrees west. And so what you do is you face north, and then you go 30 degrees towards the west. And so the wind is blowing this way. That's 30 degrees right there. But what angle would you give this line right here, this line that I wrote down. You wouldn't give it a 30 degrees. You would give it 120. Now, how do we know it's 120? Because from here to here, it's 90 degrees. And if, we're trying to use some math to help us, we always have to have a common starting point. And this is always going to be our common starting point for angles. And so we have a 120 degree angle, and our magnitude is 20 miles per hour. So we're going to write a rectangular form of this vector. What would it look like? I want you guys to take a guess right now. Think about it. And yes, you're going to use sine and cosine. If you guys remember polar coordinates, which we just hit up, x equals r cosine theta, right? And y equals r sine theta. Now, what is r in this case? Yeah, I mean, when we're talking about vectors, r is magnitude. That's our r. And so, in order to write this coordinate, we would say, let's do the I one first. The I one's going to be for your x. That's going to be, the magnitude of this one is 20, right? 20 cosine 120 degrees. Times I. Yeah, or use radians, that's fine. Plus, and then we have 20 times sine of 120 degrees. That's j. Does that make sense? That's our vector for this wind. Express its velocity as a vector v in terms of I and j. There you go.